Assalamualaikum warahmatullahi wabarakatuh. We will present PBL with the title Human Machine Interface using Raspberry Pi. Member group Noval Hanif, Arizal Fazri, my name Rizky Amelia, Rifda Nur Fauzia. Dengan manajer proyek Bapak Dr. Indah Hardian Mulyadi, ST. In science and technology, that is the development of tools to facilitate human work and increase production efficiency. One field that support is computer vision, especially in object tracking. Object tracking aims to detect and follow the position of moving objects. One of the methods used in this study in subject tracking using the YCBC color space. The YCBC color space consists of luminance component with represent RGB color and a chromate component CB and CR with represent hue and station. This method can be detect moving object, filler noise, and eliminate irrelevant motion. In this study, Raspberry Pi 4 is used as human machine interface HMI to display object tracking result. The Raspberry Pi 4 is a credit card size single board computer that can be integrated in project and device with limited space. As an HMI, Raspberry Pi serves as an interface between human and machine user, essential in the interaction and communication between the two. Raspberry Pi 4 will be connected to 7-inch LCD that matches its size and support visualization of object tracking result. This study aims to analyze the use of Raspberry Pi as an HMI in a color detection machine using the YCBC color space method. Work breakdown structure. 1. Novel Hanif, coordinator, programming object, tracking by color, analysis and collection of color data on project. 2. Arizal Fazri, PLC programming, mechanical and electrical design, PLC and HMI communication. 3. Rizky Amelia, design cover HMI. 4. Rifda Nur, GUI programming on HMI and GUI design on HMI.
Okay, in this slide I will explain about the workflow of these projects. As you can see, the first step is a literature review to study the project that will be undertaken. And the second step is system design, including mechanical and electrical designs. As you can see in here, mechanical design serves to design a concept that involves mechanical parts such as covers and equipment in the machines. And electrical design serves to design electrical system and the selections of components to be used on machines. And then project implementation involves tests such as GUI design programming, Design GUI is serves to design the appearance of the interface that will be displayed on the HMI. And camera programming. Design camera programming serves to design a program so that the camera can detect objects according to the specified color. Once all the tests are complete, testing will be conducted to determine the success of the project. The final step is research to evaluate whether the project has met the requirements or if there are any shortcomings. Okay, in this slide, I will explain about what is the flow chart of these projects. So, in the HMI, you will have any options what the color you want to detect, and the option of the color will start the machines if you push that. So, uh, example, uh, if we wanna detect of the red color in this product, so we choose the button name is red, and make sure the actuator machine is at the initial positions. If actuator machine is not at the initial positions, we must push the push start button home at the HMI. And if the actuator is at the initial positions, uh, it will be the next step, like if sensor A at the conveyor detections of the product motor conveyor, it will be start running. And if the sensor B at the conveyor detections of the product, the motor conveyor, it will be stopped, and cylinder stopper pallet product active. Next, if camera detections the color of product, as example, we wanna detections the red color, and if the camera detection the red color in this product, uh, actuator pick and place is active, and it will be move the product at the good bin. And if the color is not like we wanna choose at the first step, the cylinder stopper pallet product is will non-active, and motor conveyor will be run again, and the product will be placed at the NG product, and motor conveyor it will be stopped. I think that is for the flowchart on this project.
This time I will explain about the graphic user interface design that I made. I made a graphic user interface from Visual Studio. And for the initial appearance of the GUI, you can see it on PPT. It contains 5 boxes, each of which contain the program to be created. There is a home panel, login, start menu, camera, and PLC. For the login display menu, I create a protection with the IAM that not just anyone without permission can access other panels, so that only people who are allowed by me can change anything on the machine. And for the start menu display, made with the IAM of running the machine and saying if the PLC connect to the HMI or human machine interface. And the next camera is camera design. For the camera design in the form of a box, This is to set the camera. The camera selection box contains option to choose which camera will be connected to the HMI inside the camera panel also. Contains parameter setting for the camera and setting for the color detection.
Okay, my name is Arizo Padiri. Today I would like to do the next presentation about our mechanical design. So on this PBL, we are using the fabrication process to connect to our HMI. Because of that, we can control and do monitoring process of this machine from our HMI. So for design mechanical, you can see right here on the left side of the slide. This is the condition machine looks from isometric view. From this view, we can see there are main part or main process we have to know before using this machine. The first part is the transfer unit, and for the transfer unit, we use the conveyor and rotary cylinder, and then the sliders cylinder transfer. And then we have the drilling process to make a hole for a product. And also we can see right here, there are three indicator lamp or three indicator lights as indicates the status from this machine. So the red light to indicate the stop machine, and then the yellow to indicate the alarm state active, and then the green light to indicate the running process machine status. So for the last, we can see on the front side, there are some push button can control this machine without our HMI as the control. So I think we need to improve our mechanical design on the future to add some attribute like the bracket for HMI and then the bracket for the camera detecting object. So I think that's explanation about our mechanical design. Maybe we can go to the next slide. Okay. On the next slide, I will try to explain about the simple electrical design on our PBL. So from this drawing, you can see right here, there are some main components we need to connect with the PLC Modicon TM2341. So the first component we need is adapter 5 volts as the power of Raspberry PI4. And then the second one of my component is Raspberry PI4. And then we need the LCD wave share 7-inch to display the program GUI from Raspberry PI4. And for the last component we need is PLC TM2341 to control the sequence of program fabrication process machine. For the connection, we can see right here the power 220 volt connect to adapter and the PLC TM2341 as the power input this component. And after that, the output of adapter 5 volt will connect to the Raspberry PI4 as the power input of Raspberry. And then for the connection between the Raspberry PI4 with the LCD wave share 7-inch, We need the converter mini USB to HDMI to display the program from Raspberry Pi. And then we also need the pin connection or cable jumper between LCD Webster 7 in and Raspberry Pi 4 to give the trigger from LCD to Raspberry Pi via touchscreen. And for the last, we need the Ethernet cable to connect the Modbus TCP IP between Raspberry Pi 4 and PLC TM2341 like this. And also, you can see right here, there are three indicator line as indicate status this machine on fabrication process machine. So I think that's all about our mechanical and electrical design I can explain for this time. And thank you very much for your attention.
So in this side, I will explain about our results. So as you can see in here, I have a video, the sequence of this project. So in here, you can see the GUI settings for object detecting using the camera. So for the first step, we will choose what camera we want to use, and after that, in this test, we will attempt to detect red objects. So to initiate the detection process, we will press the button labeled red in here. And after camera detects the color red, the system of these machines will process to the next stage. This is when camera detects the red object. Okay. Based on the results of this test, we can conclude that the project has achieved the desired objective.
Okay, I will do the next presentation about the some constraint we find during we do our PBL on this semester. So actually, we don't finish our PBL on schedule because we have two problem or constraint on this PBL. So the first problem is a problem occurred while running the program. It turns out the library used, namely a forge.net, cannot be run on Raspbian. So that's mean the library of forge.net only can running at Windows Phone. So because of that, we have to change the Raspbian to be Windows on Raspberry Pi 4. That's why it takes a long time and make we out from our schedule. So for the second problem is the time is not enough because in the last 2 weeks there is a schedule of final semester exam that must be complete. So it means we don't have the time more to finish our PBL on schedule. So I think that's all our constraint on this PBL we can share for this time. So thank you very much for your attention.
The next slide is conclusion and recommendation. First, the conclusion drawn by this project is that we check the existing OS and Raspberry due to a failure when using an OS compatible with Raspberry. And the suggestion for this project is to continue the process of making covers to protect the HMI. And the next suggestion is to find a way not to check the OS and the Raspberry when you want to use it. And the next suggestion is to request an improvement graphic user interface design to display on the HMI. And thank you for the presentation. And this is our team member, Naval Hanif Marzuki, the camera program, and Arizul Fajri is PLC and communication, Rizky Amelia is design, HMI cover, and Rebdanul Fauzia is GUI program. Okay, thank you very much and see you